Okay, Deidre, I'll make you a real quick one here because you need 6 to do 7 and 8. All right, so here you go. And let's just go ahead and take a look at the kinematic equations real quick. I'm just going to write them down. There's only 4, okay? And I know it seems like so the distance an object goes is its average speed times the time, okay? And so you could use that one if you wanted to find how far it went, and you'd be done. Okay, and because you computed earlier that it reached a top speed, we figured out that its top speed at the end was equal to 119 meters per second. You got that, okay, and its initial velocity was 0, so therefore its average velocity would be 119 plus 0 divided by 2. That's easy enough. All right, and then you can just multiply that by 4.38 seconds, and you're done. That's how far it went. That's one way to do it. The other way to do it, and you had to find the acceleration, but you had to find the acceleration. Well, the acceleration is equal to 119 minus 0 over 4.38, which comes out to be huge. It comes out to be 27 meters per second squared. That's huge. Okay. All right. So, and we also know this. We know that v that x also equals v naught times t, where v naught is equal to 0 in this case, plus 1/2 a t squared. So again, if you find the acceleration, which is just this, and then you got the acceleration right here, and you go, oh well, x is equal to, and you can do this on your calculator, 0.5 times the 27 times the 4.38 squared. Don't forget to square it like you did last time. That'll get it. And or the other way, there's 2 other ways to do it. You can do v final squared is equal to, because this is the last kinematic equation. Here's 1, here's 2, here's 3. Well, this is kind of tied in there, and here's 4, and here's 5. This 3 is really kind of 2a or whatever. All right. Okay. V final squared plus 2a times the distance that it went times x. All right, we'll just keep it that way. Hey, you got this guy. This guy's 0, and so you can take, well, v final squared over 2a. That'll work. That'll get it too. Any of those will work. And if you don't believe me, let's do that real fast. Let's take this. So this would be 119 squared over 2 times 27. And this would be this one. Okay. So I'm going to go ahead and plug in the numbers for this one, and I hope I get the same thing. If I don't, then I'm fired. All right. So it's 0.5 times 27. Oh, I'll let you see what I'm doing. 0.5. First of all, because I did an arrow instead of times 27 times parentheses 4.38 squared, 258 meters, or 256 meters. Let's call that 256. Let's try this one. 119 squared divided by 2 times 27, put all that in parentheses. Look at that, 268, pretty close. It's because of rounding. I'd go ahead and use this one, because this one has too much rounding going on inside it, okay? And when you start squaring the rounding, but you can see that they're real close. I mean, what's 6 meters when we've already gone 250? Well, it's quite a bit. If you're doing a moonshot, you don't want to do that. All right, there you go.